My name is Adedunke Gomina, and this is sbfrequency events. Today, we're going to be talking about matching amplifiers with speakers using ohms and power. Let's get right into it. So before we can match our amplifiers with our speakers, we have to consider so many things. Now, a lot of engineers or volunteers or people that handle audio equipment use just the power rating of the amplifiers to match the speakers. Actually, there's another factor that needs to be considered, which is the ohms, which is the impedance with nominal impedance of the speakers and the amplifiers. So today we're going to be showing you how to do that and how to achieve the best results from matching your speakers with your amplifiers. Now, before we will go further, we have to consider the speaker impedance. Now, what do we mean by speaker impedance? Speaker impedance is the measure of how much the speaker resists the flow of electrical current coming from the amplifier. Now, this is measured in ohms, and for every speaker, right, it has a value which is the speaker impedance on it. Now, how do we know what the speaker impedance is for each speaker that we see? It's always written at the back of the speaker, and for most brands, it's actually in the manual that comes with the speaker. So it's actually important that we check what the speaker impedance is for whichever speaker it is that we're using. Now, you must actually note that it is important for you to match your speakers and your amplifiers properly, because if it's not matched properly, you would have situations whereby your speakers will blow. I'm sure you must have seen situations whereby some speakers will catch fire, right? Or if you've been having issues in your church or at your workplace where the speakers are always burning or the tweeters are always burning, right? And you have to look at your matching of your amplifiers to your speakers. It is important that you don't just match those speakers based on wattage. You have to pay attention to the ohms matching, because it's the ohms value that the amplifier sees that determines how much power it's going to be sending to the speakers. So you have to take notes to match your speakers and your amplifiers properly to avoid blowing your speakers catching fire, to avoid stories that touch the heart, or blowing up your amplifiers. I'm sure some of you don't have your amplifiers lasting long. It's because you are overworking your amplifiers, or some of them you are actually connecting them at 2 ohms, which the amplifier cannot handle. So at the end of the day, you end up overworking the amplifier, you end up damaging the amplifier. It is essentially the speaker's electrical resistance that dictates how much current the speaker draws from the amplifier for a given voltage. So the lower impedance means that the speaker draws more current, leading to higher output. And what this means is that when there is low impedance, it means that there is low resistance to the flow of electrical current. And that means that it would actually receive more output of power from the amplifier. Also, higher impedance means that the speaker draws less current, leading to lower output. And as we know with the Ohm's law, right, we know that power is directly proportional to the square of the voltage and inversely proportional to the resistance, provided that the current is actually constant. Now, that is Ohm's law. And from the formula we can see over here, we can see that power is equals to voltage square divided by the resistance. That means that power is inversely proportional to resistance. So that means that if I'm going to be increasing the resistance, it means that I am going to be getting lower power. And if I'm going to be reducing the resistance, then I'm going to be getting a higher power. So I hope that's actually understood. So the next thing that we're going to be looking into is series and parallel connections. Now, I haven't explained what I mean by impedance. Now, this impedance value, we can see it on speakers and on amplifiers too. But what happens when we connect more than one speaker together? Are we connecting in series or are we connecting in parallel? Now, for ceiling speakers and those kind of speakers, most of the connections that are done with ceiling speakers are actually series connections. But the connections that we do in live sound, when it has to do with full range speakers, line array speakers, floor monitors, right, subwoofers, those connections are called parallel connections. Now, a lot of people mix up parallel connections. For example, if I'm connecting two speakers to one channel of the amplifier, and I am looping the first one to the second one, and from the second one it goes to the amplifier. Some people used to think that that's a series connection. That is not a series connection. That is still a parallel connection. And that's because when you connect from a speaker and you loop to another, if you check that speak-on port, it's actually called a parallel out or a parallel loop out. Now, even though physically it looks like it's a series connection, but it is a parallel connection. So you must take note of that, that even if you're looping from one speaker to the other, it is still a parallel connection. And even if you actually connect two speakers, right, directly to one channel, like some people locally, we actually loop two cables together, right? And that end goes directly to the back of the amplifier, to one channel of the back of the amplifier, right? That connection is still a parallel connection. So either you're looping from one to the other, or you're joining the two together to go directly to the back of the amplifier, it is still a parallel connection. So having established that, how do we calculate the impedance when we are connecting in series and we're connecting in parallel? We're about to show you that. So for the series connection, the formula is RT is equals to R1 plus R2 plus R3 plus R4, where RT is the total resistance, R1 is the speaker 1 impedance, R2 speaker 2 impedance, R3 speaker 3 impedance, R4 speaker 4 impedance. So this means that for as many number of speakers we're going to be looping together in series, how do we get the total number of ohms that the amplifier is going to see? We are going to be using this formula. So here we have an example, and it says, for example, the total impedance of 4 ceiling speakers with nominal impedance of 4 ohms, each connected in series, will be. So introducing our formula, we have RT is equals to R1 plus R2 plus R3 plus R4. RT is equals to 4 plus 4 plus 4 plus 4. And the total impedance that will be seen will be 16 ohms. So that brings us to our parallel connections. Now, when we're connecting in parallel, it's a total different ballgame entirely. The formula we're going to be using to calculate the total resistance or impedance will be 1 over RT is equals to 1 over R1, 1 over R2, 1 over R3, till based on the number of speakers we're going to be connecting in parallel. Now, for example, if the total impedance of two speakers with nominal impedance of 8 ohms, each connected in parallel, will be, so we would introduce our formula. So here we have 2 speakers and each one of them are actually 8 ohms. So we would have 1 over RT is equals to 1 over R1 plus 1 over R2 plus 1 over R3. Then 1 over RT will be 1 over 8 plus 1 over 8. By the time we actually do the maths, if you know LCM and all that, so you would have 1 over RT is equals to 1 over 4. And by the time you invert it, you'd have RT is equals to 4 ohms. So that now tells us that the total impedance that we're going to be getting will be 4 ohms if we're going to be connecting 2 speakers in parallel. So a a lot of people don't know this, right? So most people will just assume that, okay, if I'm connecting two full range speakers together and each one of them is actually 8 ohms, then the total ohms is going to be 16 ohms. No. The amplifier is going to be seeing a 4 ohms load and not 8 ohms and not 16 ohms. So that's how to actually calculate the actual total impedance that your amplifier is going to be seeing when you're connecting in parallel or when you're connecting in series. So that brings us to what we know as the nominal impedance. Now, speaker manufacturers often specify a nominal impedance, which is the value used for matching. So when we want to match speakers and amplifiers, we actually have to check the manual of the speaker to check what the impedance value is. And that impedance is the nominal impedance, which is the average impedance, right? That is calculated over a period of time. That's the nominal impedance. So it's always given in the manual, or you can check at the back of the speaker, right, where you have that speak-on connector. It's always written there. And it is crucial to match the impedance of your speakers to the impedance rating of your amplifier. If a speaker's impedance is too low for the amplifier may overheat and shut down. Also, some amplifiers will keep tripping off once the impedance is not matched. Now, there are some products, for example, the Crown amplifiers, right? Some of them in their manual, they tell you that it only works at 4 ohms. So if you're connecting a load of impedance that is above 4 ohms or less than 4 ohms, the amplifier will keep shutting down. So I've had such experience before, over 15 years ago, when we just, got to see the Crown amplifiers, and we connected it to an 8 ohms load, and we just noticed that the amplifier just kept shutting down, and we felt that the amplifier wasn't good. No, the amplifier was in perfect shape. What just happened was we were connecting the wrong load to that amplifier. So now some amplifiers actually give you a range of loads that you can actually use the amplifier with. For example, the Waftel amplifiers, so many brands of amplifiers out there, they actually tell you that it can handle 2 ohms load, 4 ohms load, 8 ohms load, So depending on what you want to connect, right, that amplifiers were designed to handle those categories of impedance, right? But for speakers, the impedance or the nominal impedance is fixed for all speakers. So all speakers actually work with a particular value, and it's given in the manual or written at the back of the speaker. But for amplifiers, depending on the brand or the manufacturers, right, you can have some that tell you it only works at 4 ohms or it only works at 8 ohms, and some will tell you they can handle 4 to 8 ohms, and some even tell you it can handle 2 ohms load. Now, you must note that it's actually advisable to avoid a 2 ohms load on most amplifiers, because that actually overworks the amplifier and makes them to actually overheat. A lot of amplifiers can't undo the 2 ohms load. So I must state that, and it's always good to avoid that when connecting multiple speakers to your amplifiers. So here, as we can see a picture. So I'm going to be using an illustration of this speaker we have over here is the EVP, Waftel EVP speakers. It's a 215 speaker. And as you can see in this picture, at the back, there are things written there that are scribbled there. Those are the actual ratings of that speaker. Now, you must note that behind each of these speakers, they don't give you the full information of the power rating. They just give you what the RMS or the continuous. For some products, for the sake of marketing, they will write the peak value and not the continuous value of the speaker. Now, let me explain that. Now, for every speaker manual, that you can see. I have one over here. Now you can see here it is written the impedance here, and the impedance here is 8 ohms. Now when we come to power, we can see we have the RMS and we have the program and the peak. Now most times for most brands, they actually write the power rating at RMS, and that is what they put behind the speaker, and they also write the nominal impedance value, which is 8 ohms, right? But for some products, for marketing sake, so that you can feel like the product is actually producing more power than it's supposed to, instead of writing 500 watts, they will put 2000 watts with a sticker boldly written in front of it. So you would think that it's a 2000 watt speaker, whereas it actually does 500 watts. And some of those stickers, it will be written there with a very tiny ink, peak, right? But because you're not looking closely at that, you just assume that the speaker can do 2000 watts. No. So you have to maybe check the manual to be sure that it's to be sure of the power rating at RMS, right? So this is an example of a manual, and this manual here you can see here is that of the EVPX 215 that we have over here. So next thing is when we match amplifiers with speakers. Now, the major rule for matching amplifiers with speakers is that an amplifier of power rating of 20% above or below the continuous rating of the speaker should be used when matching amps to speakers. That's the rule. Now, I've seen a lot of school of thought. Some people will say that you should do double the power rating of the continuous rating of the speaker. But we actually say here that we do 20%, and it should be 20% above or below the continuous rating of the speaker. And this actually gives enough headroom so that you don't have issues of overloading the amplifiers, and also you don't have too much power going into the speakers. Now, reason for this rule is this. We use the continuous rating because you want to connect your speakers at the continuous rating or the RMS rating. Now, we will not use the peak rating because we're starting with the continuous rating. For example, if we look at the WAFDL EVPX 215 speaker that we showed earlier, we can see that the continuous rating is 500 watts. Now, we would use that RMS or continuous value of 500 watts because we're giving room in case if too much power is going to go into that speaker. If we know that when our amplifier clips, actually, it brings about double of the voltage, double of the power, right, into our speaker. For example, if my amplifier is actually doing 600 watts, right, at 8 ohms, for example, and I end up clipping that amplifier, what's going to happen is that I'm going to be sending a power of 1200 watts, right? Because when the amplifier clips, it doubles the power. So I want it to be that even if my amplifier clips and that sound goes into my speakers, right, it is still going to be fair enough. That power will not reach the peak of my speaker, which is 2000 watts. I will still have enough headroom even though that amplifier clips, and that will ensure that my speakers will not burn, right? So that's the reason why we always do our connection and our matching at the continuous value or the RMS value of the speaker. So let's use this speaker as an illustration. And as you can see here, I have the specification of this speaker written here. Now, for that speaker right now that is 500 watts, right, at 8 ohms, I would have to look for an amplifier that is 20% above or below the power rating. And the amplifier can be maybe 400 watts, 500 watts, or 600 watts at 8 ohms per channel. And this kind of amplifier is what I'm going to be matching with my speaker. So looking at this manual right here, below here I have the WAF-Del MP series amplifiers manual, and I have the MP1200, I have the MP1800, and I have the MP2800. Now, based on the value that I have, which is 500 watts at 8 ohms, the amplifier that I believe is going to match this is the MP2800, which is 600 watts at 8 ohms. Now, if you look at the amplifier rating, right, this particular amplifier can do 8 ohms, 4 ohms, and 2 ohms. And it's also giving me the equivalent power that is going to be generating. If it sees a 2 ohms load, it's going to be producing 1,450 watts. If it's a 4 ohms load, it's going to be producing 950 watts. And if it's an 8 ohms load, it's going to be producing 600 watts. So the best amplifier I'm going to be using for this speaker will be the MP2800, which is 600 watts at 8 ohms. So I hope you actually understand that. So let's look at another illustration. Now, if I have two speakers that I want to loop together and connect to one channel of my amplifier. So here I have the EVPX15, and as you can see here, for example, looping or connection in parallel of two WAF-Del EVPX15 speakers with the following rating of each speaker. So this is the rating of this speaker, which is 300 watts continuous, 600 watt music, 1,200 watts peak at 8 ohms. So like I said, we have to firstly calculate the total resistance or the total load or impedance that is going to be seen, right? So we would use the parallel connection formula, which is 1 over RT is equals to 1 over 8 plus 1 over 8, which gives us 2 over 8. When we invert this, then we get RT is 4 ohms. So the total resistance seen is going to be 4 ohms. Now, the next thing we have to do is to calculate the total power that is going to be seen by the amplifier. And to get the total power, we're going to be using this formula, which is PT is equals to P1 plus P2 plus P3, meaning we're going to be adding up the wattage of each of those speakers together. So that's each one of them is 300 watts, and 300 plus 300 gives us 600 watts. So the total power the amplifier is going to be seeing will be 600 watts. So we then need to find an amplifier that is 20% above or below the total power, which is 600 watts at the total impedance we calculated earlier, which is 4 ohms. So when we look at the amplifier we have here, we have the MP1200, we have the MP1800. So this one seems like a perfect match, which is at 4 ohms, it's delivering 600 watts, which is exactly what we have here calculated, 600 watts at 4 ohms. So we can actually fall back on the MP1800 amplifier and use it to connect the two EVPX15 speakers looped in parallel. Now, for some people that actually go with the double row, right? Like we said, we actually use the 20% above or below exactly, right? For the double row, the MP2800 amplifier can be used because if you look at this, it's actually going to be delivering 950 watts at 4 ohms, and double of the 600 watts is around 1,200, which is actually close. So some people would rather prefer to use the MP2800 amplifier, but we will use the MP1800 amplifier. Now, we all know that there are many schools of thoughts when it comes to ohms and speaker matching. And also, some people also consider what we call the sensitivity of the amplifier when matching speakers. This video is specifically to address matching speakers with amplifiers with ohms and power rating. Now, if you want to know more or learn more about everything that we've done on audio engineering, you can come for any of our training courses. We have our courses online or physically in Abuja, Nigeria. And also you can contact us on all our social media platforms. We're on Instagram, we're on Facebook, we're on Twitter, we're on YouTube. Also, please make sure you subscribe to our YouTube channel, as this will help us grow more and bring more videos to you. Yeah, so till when next you have us, this is SB Frequency Events. Bye.